Welcome back. This video will be an introduction to heat capacity and specific heat capacity. Heat capacity is defined as the energy required to raise the temperature of the entire mass of an object by 1 degree Celsius. It can also be defined as the energy required to raise the temperature of the entire mass of an object by 1 Kelvin. What that simply means is, if you have an object, let's say it weighs 9 kilograms. Here, the heat capacity is the energy that is required to increase the temperature of the total 9 kilogram mass by 1 Kelvin or by 1 degree Celsius. So let's say, for example, the heat capacity of water is 2100 joules per Kelvin. What that simply means is that for a certain amount of water, it requires 2100 joules of heat energy to increase the temperature of that water by 1 Kelvin or by 1 degree Celsius. Moving on, the unit of heat capacity is joule per Kelvin or joule per degree Celsius. That is, for the joule per Kelvin, you can also write it as J K to the negative 1. And for the joule per degree Celsius, you can write it as J degrees Celsius to the negative 1. That is heat capacity. Okay? But we need something more specific called the specific heat capacity. So if you can recall, we've talked about the 9 kilogram mass of water when we were dealing with heat capacity. But let's say now, out of that 9 kilogram mass, we only want to know the amount of energy that is required to increase the temperature of just 1 kilogram mass by 1 Kelvin or by 1 degree Celsius. That is called specific heat capacity. Specific in the sense that we are giving reference to 1 kilogram mass. That is just 1 kilogram mass. We want to know the amount of energy that is required to increase the temperature of 1 kilogram mass of an object by 1 Kelvin or by 1 degree Celsius. So a typical example is water. The specific heat capacity of water is approximately 4,200 joules per kilogram per Kelvin, okay? Which you can also write as 4,200 joules per kilogram per Kelvin. Now, what that simply means is that it requires 4,200 joules of heat energy to increase the temperature of 1 kilogram mass of water by 1 Kelvin. If you want, you can say by 1 degree Celsius. Just know that the Kelvin and the Celsius are numerically equal when dealing with heat capacities and specific heat capacities. So moving on, we've said that the unit of specific heat capacity is joule per kilogram per Kelvin. That is written as this way, or if you want, you can write it this way, or we can say joule per kilogram per degree Celsius. That can be written as this way or this way. So to summarize it, when we talk about heat capacity, we are talking about the entire mass of the object. But when we refer to specific heat capacity, we are just referring to just 1 kilogram out of the entire mass of the object. Okay? So what is the key differences that we have to know? Coming to the differences between heat capacity and specific heat capacity, we said that the heat capacity is the amount of energy required to raise the temperature of an entire object by 1 Kelvin or 1 degree Celsius. For specific heat capacity, it is the amount of heat required to raise the temperature of 1 kilogram of an object by 1 Kelvin or 1 degree Celsius. So stating that 1 kilogram mass in the definition is very important. It is represented with the capital letter C for heat capacity. For specific heat capacity, it is represented with the small letter c. The unit of heat capacity is joule per degree Celsius or joule per Kelvin. But for specific heat capacity, the unit is joule per kilogram per degree Celsius or joule per kilogram per Kelvin. So heat capacity depends on the mass and size of the object, but specific heat capacity does not depend on the mass and size of the object. It is specific for the object that is in question. Okay, for example, the specific heat capacity of water does not change, is approximately 4,200 joules per kilogram per Kelvin. But the heat capacity of water can change, okay, depending on the mass of the object. The formula relationship with specific heat capacity is the heat capacity C is equal to mass times the specific heat capacity. The formula relationship with heat capacity is that specific heat capacity is equal to the heat capacity divided by the mass. The relationship with the quantity of heat, that is Q, is heat capacity multiplied by change in temperature, that is delta theta. The relationship with the quantity of heat is Q is equal to mc delta theta. So these are the useful formulae that we have regarding heat capacity and specific heat capacity. Always what you have to remember is that the capital letter C is for heat capacity, the small letter c is for specific heat capacity. Okay? Q is the quantity of heat that is supplied or removed from an object. Remember, if you supply heat to an object, its temperature increases. So which means the final temperature becomes higher than the initial temperature. But when an object is allowed to cool, or when heat is removed from an object, what happens? Its final temperature becomes lower than its initial temperature. So quantity of heat basically talks about both cases, whether heat is supplied to an object or is removed from an object. All right. M is the mass of the object. Theta 2 is the final temperature of the object. Theta 1 is the initial temperature of the object. Delta theta, that is change in temperature, is by subtracting the two temperatures that you are given. Okay, so if the object is gaining heat, which means the final temperature is higher than the initial temperature, so we're going to use theta 2 minus theta 1. That is, there is gain. But if the object is losing heat, it means the initial temperature is higher than the final temperature, or in other words, the final temperature is lower than the initial temperature. So we will have theta 1 minus theta 2. We're doing it this way because we want to have a positive temperature difference. Okay? So P is the power, I is the current, V is the voltage, T is the time taken for change in temperature to occur, and R is the resistance. All right? So what is important to note is that the quantity of heat Q is equal to the mass of the object times the specific heat capacity times the change in temperature. So that change in temperature delta theta can be theta 2 minus theta 1 if the object is gaining heat. That is, the final temperature will be higher than the initial temperature. But delta theta can be theta 1 minus theta 2 if at all the object is losing heat. In other words, the initial temperature is having a higher temperature than the final temperature. So we also have the quantity of heat is equal to the heat capacity multiplied by change in temperature. Okay, this is capital C. So this second formula is usually forgotten. Always try to remember that. Okay, they can ask you to find the quantity of heat even if you are not given the specific heat capacity. But if the heat capacity is given, you just have to multiply it with the change in temperature to have the quantity of heat. Okay, so we also have to know that the quantity of heat is the same as the power multiplied by the time. Okay, and since power is equal to the current times the voltage, we can say the quantity of heat is equal to the current times the voltage times the time. You can remember this formula very well in electricity. The voltage is equal to the current multiplied by the resistance. So we have already discussed about power, which is the same as the current times the voltage, measured in watts, or in other words, it is measured in joule per second. We have the final formula here that the heat capacity is equal to the mass times the specific heat capacity. So the two formulae that you should not confuse or should not forget about is this and this, okay, where heat capacity is involved. For this one, quantity of heat is equal to the heat capacity times the change in temperature. For this one, the heat capacity is equal to mass times the specific heat capacity. Okay, the other formulae, they are easy to remember. Okay, so in our next video, we will begin to solve problems related to heat capacity and specific heat capacity. Thank you very much for watching this video. Please subscribe, like, and share our videos.